Hello, this screencast of GeoGebra is going to show you how to construct two congruent triangles within a parallelogram. I've opened GeoGebra, the Chrome app, and am provided with 6 options. I will left-click Geometry. I'm going to left-click on the style bar. I'm going to add axes and a standard grid. Just going to adjust the axes so there's lots of room in quadrant 1 for our construction. I'm going to go ahead and construct a segment in the first quadrant. So I've just added 2 points, point A and B. Now I will choose segment and just select A, then B. And now I have a segment AB. I am going to rotate this segment. So I will go rotate around point. I will first select the object and then the point of rotation. 45 works for me now, 45 degrees counterclockwise. Here we go, we've rotated segment AB. Now we have angle B prime AB and, rather not and, but of 45 degrees. I'm going to translate segment AB up here to B prime. Selected, I'll choose my vector, and there we go. Now we've translated AB. Now we have A prime, B prime. Let's try something a little fancy here. I am actually going to construct a line through B and B prime. And then I'm going to reflect this part here. I just realized my mistake. If I reflect that, that's actually going to be more of a chevron versus a parallelogram. So I'm just going to go ahead and undo that. Now I'm going to go ahead and simply translate the ray A prime. And there we have a simple parallelogram. Just going to choose the select tool here. I'm just going to left click and then hide, or rather change some of these, the way it's been labeled to B prime to B. I'm just going to hide some of these labels here. Left click and then right click, then left click, show label, so it looks a little less cluttered. So I have A double prime, B double prime, A prime. I'm just going to hide this vector and just reconstruct this with a segment. And I'll do the same thing down here. I'll left click, right click, show object, do it twice, and then I'm just going to, that was a mistake. Just going to add a segment here. There we have a simple parallelogram. I'm just going to construct the interior, so I left click, polygon, and I'll just go in sequence to construct the interior. I'm just going to change the labels here. Change this, rename it rather, to, well, actually it says B. I'm just going to seems I can't. Fine, I'll just leave it as it is. We have parallelogram A prime, A double prime, B double prime, and it looks like another A double prime. Let's see if I can rename that. Doesn't matter. Oh, here we go. Let's just resize this, and we see if we drag, it still respects its parallelogram properties. Just enlarged it here. There we go. So now we can see the parallelogram, and we'll just go ahead and construct the two triangles within the parallelogram. I'll just choose a segment here, bisect the parallelogram into two congruent triangles. I'm going to just do some measurements now before I'm finished. There. So now I've just constructed the triangle here. We'll go ahead and do some measurements. There, we've added some measurements here, and I'll just go ahead and construct a segment here. This will give us the height of both triangles. I'll just do an intersection here. Intersection E. I'll just go ahead and measure a couple of angles. Other way. Both are 90. We'll drag it over there so it's a little cleaner. 90, 90. We'll go ahead and measure the height. The height is 5.54. The base is 4.59. Let's clean that up a bit. So now we have two congruent triangles within a rhombus parallelogram. The two triangles both have a base measurement of 4.59 centimeters and a height measurement of 5.54. Last thing we'll do is just go ahead and calculate the area of one, which will give us the area of both of these triangles. Just looking for the spreadsheet. Here we go. So I'm going to put in base, I'm going to put in height, and I'm going to put in area. So the base is 4.59. The height is 5.54. And I'll just use my knowledge of spreadsheets. I will do an equal sign to show that a formula or a number sentence is coming. I'm going to select this, choose multiply, which is the asterisk, and then the height, and then enter. The area of the rhombus is 25.43. I'll just write that in here, area of the rhombus, and the area of the triangle is going to be equal to this divided by 2. Oh, that's not what we wanted. Try that again. Equals this divided by 2. There we go. 12.71. Let's go ahead and just let GeoGebra help us with that. We'll go ahead and just use GeoGebra to determine the area. The area, we'll select this. This is the area of the rhombus, 25.46. We see some rounding issues here, but alas, it is virtually the same. And then the area of the triangle, it's the same thing. We'll just undo that. And there we are. We have the constructed parallelogram or rhombus within the first quadrant of a Cartesian grid. We have constructed two congruent isosceles triangles within the parallelogram. We have measured some of the angles. We have the angles within the parallelogram that show the height. Remember, the height of a triangle is at 90 degrees to the base. We have the base measurement of 4.59, the height measurement of 5.54, and thus the calculated area of the triangle as 12.71. The area of the entire parallelogram rhombus is 25.43. And we can just do one more thing. We can say the area of two triangles will just be this times 2, and it's the same here. So we have successfully completed our construction. Thanks for watching, and have a good day.